Welcome back again, and this time we'll be discussing the RHESSys calibration workflow, which I'll open up here. Now this workflow is the most exciting for scientists because calibration of RHESSys is a very time-consuming and daunting task. And as you may notice, there's a lot fewer RHESSys parameters, and that's because they're currently stored in the RHESSys composite actor, because we're going to be actually calibrating them, or finding out which values best suit the watershed we're calibrating for. So how you begin this process is you have to configure the gen parameter sets. I can either double click on the actor, right click and configure the actor. So it stores a small R script where we'll be calibrating MK alt 1 2 groundwater 1 and 2, and the rest of this is just how the parameters are actually distributed to the next part of the workflow, or sent to the next part of the workflow. So, and as a scientist, you'll be a lot more familiar with how you actually specify or which range you want, which range you expect for the min and max of M and the min and max for K. This is just an example here, but you also notice there's a number of samples. So if I go back, that's this parameter here. So typically when you do RHESSys calibration, you use 25 samples, and then within those 25 randomly distributed samples, you run RHESSys for each of those samples, and at the end you're going to do analysis on which ones are closest to your observed values. So the first part, which I just showed, is actually generating the parameter sets for as many as we want, and then actually running RHESSys for each of those sets. And the rest is the same as the parallel actor in combining the file, except the file is combined in a different way for the actual calibration process than it was before, but I won't go into that. And then it turns out the file is actually small enough, usually you can copy it back to your local machine and do our analysis on your machine using Kepler instead of having to do it on the remote system. So, but this step will need to be refined. Currently, this is the script that was actually used on the remote system, so I'm sure it can be rewritten and better utilized to fit within Kepler, because there's several graphical displays you can use, and there also needs to be, or it should be possible to develop, I would say, almost a fully automated system where it can feed back into the beginning R script and tell it how to adjust parameters once you figure out how you're going to perform the calibration process. So once again, running it's exactly the same once you've configured everything. So with the exception that now you do have to worry about R. So what I've done here is I've specified my home directory on the system, but also the directory where we'll be storing copied files, as well as some other files that R will generate, including a copy of what parameters were used. So later you can go back and look and see what parameter sets were actually generated and correspond to each run, because that is important information for doing the feedback process.